In this video, we're going to look at an exception to the 5-step method in an electrolytic cell, specifically involving the electrolysis of brine and the chloride anomaly. If we envision an electrolytic cell in which we have a battery connected to two carbon electrodes, on the left we have our anode, and on the right we have our cathode. And these electrodes are immersed in a solution of sodium chloride. If we were to do the 5-step method on this electrolytic cell to determine the two reactions, we would start by listing what species are present in the cell. So we have sodium ions, we have chloride ions, and we have water. Because our electrodes are inert, we don't have to list them. If we examine our reduction table on page 8, we'll see that water is both the strongest oxidizing agent and the strongest reducing agent in this cell. So our expected reactions would be oxidation of water at the anode. So we would expect to see the following half reaction. So water oxidized to oxygen, hydrogen ions. And so what we would expect to see in terms of observations would be bubbles owing from the oxygen gas that's produced. And we would expect to see a drop in pH from the production of hydrogen ions. At our cathode, where we see reduction of water, we would expect to see hydrogen gas and hydroxide ions. And so in terms of observations, we would expect to see bubbles from the hydrogen gas and an increase in pH from our hydroxide. The bubbles that we would get from oxygen, we could test with a glowing splint to confirm it was in fact oxygen. And the bubbles from hydrogen, we could test with a pop test to confirm it was in fact hydrogen. So these are our expected observations or expected reactions. And we do see this reaction at the cathode, so the production of hydrogen gas and hydroxide. We do not see the expected observation at the anode. Instead, we see the production of yellowy green bubbles and the scent of chlorine. That indicates to us that instead of the oxidation of water, what actually occurs at this anode is the oxidation of chloride ions to form chlorine gas. And chlorine gas is the bubbles that we see. So these are the actual reactions. And so this is called the chloride anomaly. And the chloride anomaly is that when chloride ions and water are the only RAs present, chloride ions will be oxidized before water, even though they are a weaker reducing agent. And the reason for this has to do with how easy it is to transfer electrons from the solution into the solid electrode. And it ends up being easier to transfer electrons from chloride than it is from water. And so when we examine how much electrical potential is needed to run this cell, what battery we require, the voltage required is the difference between the two half reactions that actually occur. And so this is one exception where the five-step method falls apart. There's not a lot of these exceptions, and this is the only one that you're required to understand and to know.